Hi everyone, welcome back to part 4. In the last video, in part 3, we made this surf function that will return, that will basically give us the circles that we're looking for. So now in part 4, we're going to vectorize that function and we're going to use that to generate basically um, our wireframe pipe that goes around our central helix. Okay, so the first thing we want to do is vectorize this function, this surf function. And the way we're going to do that is with with a function in Jax called Vectorize. What this does, it takes in a function um, and it basically adds dimensions to it to vectorize it. And we'll probably put in a signature. It is optional, but we'll probably go ahead and put in a signature. So I'll say surface, a new function, or I guess a variable, but vectorized equals Jax numpy dot vectorize. We need to specify the function we want to vectorize, so surf, and then our signature. And for the signature, we're going to put in a scalar and specify 2, 3 dimensions. Okay, so now if we run that surf vec with t and theta, we should get an error. Oop, we need an arrow here. Okay, incompatible shapes. Okay, so right now these t and theta aren't the correct array size. We need to add a dimension to them. So the way we'll do that is we'll just say that t needs to add an empty dimension on the end, and then theta will add an empty dimension at the beginning. Okay, so that's what our surf vec looks like. And I'm going to say that S1 equals that. So, dot size, and actually I'm just going to go ahead and restart and run everything to make sure that we are good to go. Okay. Okay, so dot size, or we'll do S1 dot size. That's not what we want. We want to look at the shape, not the size. So shape, what we have here is 50, 25, and 3. So this is 50. This 50 is our t values, so every t value. This 25 is our theta values. So we have 50 t values, 25 theta values, and then this 3 is our x, y, and z values. So what we want to be able to do is pull out the x, y, z values that carry the t values and the theta values with it. So what we're going to do first is use the transpose, S1 transpose, and what that actually does, it just flips it around. So this 3, the x, y, z is at the beginning. So that's what we want. So I'm going to say S2 equals that. And then if we look at S2 dot shape, it should be exactly the same thing, 325, 50. So now what I want to do is I want to take out x, y, z values and carry the 25 and 50 theta and t values with it. So I'm going to say x, y, z equals S2. And now actually, if I look at x dot shape, we have our 25, 50. So for the x values, there are 25 theta values and 50 t values. Y will be the exact same thing, 25 and 50, and then z will be the exact same thing. So now that we have those, I believe I can just go ahead and plot it. So I'm just going to use what we did before here. We'll make that a comment. And what I want to do is I want to take, for every theta value, I want to take the x value and the t values, and, well, for every theta, I want to plot all the x values that correspond with that value of theta. So the way I'll code that is for I in range theta dot size, we will put a line. So there should be 25 total lines, I believe. And that line, we wanted to take, so we wanted to go into that x, into that x array that we looked at up here, the shape of that x array, and we wanted to take every value from the first index there. So I believe we specify that like this. And then I will just plot the figure. Python should go ahead and sketch that out for us. And we have some circles. So that's not exactly what I wanted. Since we're plotting x values for every theta, there should be lines going around all the way up, kind of parallel with the helix almost, parallel with the center. So I think what I did wrong here is these need to be switched. I think this needs to be that must be the problem. The first index, and then every value from it. Or if I run that, I believe this should fix it. Okay, yeah, so here we go. So every line is for every theta value. So there should be 25 lines if we were to count them. But now what I want to do is I want to plot the actual circles that connect all these theta values. So it's going to be the same type of thing here. But instead of theta, we're just going to do t. So that we're going to plot all the t values and the circles that go with them. So now I'm going to switch these back. So the circles that we saw before is basically going to be what we're plotting now. If I go ahead and run this, we should get the wireframe pipe that we were looking for if this runs. So here we go. So we have the circles going around the central helix, and then we have all of these lines that make up the pipe that's a radius of 0.5 away from the center. So I'm actually going to go ahead and change the colors on this, just to make it look a little nicer. We'll do black. I should be able to copy paste this down. And then that should be the end of it. There we are. So here's our pipe. So that was the end of part 4. We generated the plot of the surface with the pipe that has a radius of 0.5, and it follows the curve that we defined above, the helix. So here we are. Here is our 3D wireframe pipe. Thanks so much for watching.